Yeah, so recording has started. So welcome to today's tutorial. Going through record structures, right? So what I would do is I'll start with the diagram first, then we go through the slides. So I'm gonna open Chrome, draw.io. Okay, create a new diagram. I'll call it records, and then create, save. So if you still remember, we talked about variables, right? Variables are like boxes. And I did talk about arrays, that it's like multiple boxes stored under one name. And we can access each box at a specific position. That position, we call it an index in informatics. So if you still remember an array, so just gonna recap on that. Just just recap on that quickly. So if you remember, arrays are like this, right? So it's like you can view them as like drawers, whatever you want to view them. But then they're like this, and then each of these has a box or a variable. Remember, a box represents a variable, right? So all of there they are, the boxes, right? And each box doesn't have a name. Remember, when we created variables previously, we give it a name, right? Whereby the name acts as a label on the box, which describes what is stored inside the box. And then it also has a data type, which describes the thing that is stored inside the box. What type of thing is it? Is it a liquid? Is it a solid or something like that? So in the case of arrays, right, you only have data types. And then each array, each box or each variable is stored at a specific position. And you start counting from position 0. That's just how the counting works inside a computer. It's not like us when you're at a queue, especially if you were at a queue today. I'm sure you would have been annoyed, especially the queue at Capitec month end. So it's like that queue, right? Whoever is the first person, we say that's person number one. Whoever follows him, that's person number two, and so forth. So we usually start counting from one if we are counting things. Excuse me. In terms of computers, right, they start counting from 0, not 1. There is a deeper reasoning behind that, but it's not important for you guys since comsci or informatics are not your majors. So I won't go into those details. But for now, just know it's enough to know that it starts counting from 0. And then, like we said, each box has a data type. And an array, right? You need to also understand something deep about an array. All of these boxes, they store the same thing. You're not allowed to create an array that can store different types. So if you want an array of integers, all of the boxes should be able to store an integer. That's the sort of like limitation with an array, right? I want you to keep that in mind because we're gonna go back to that when we start talking about record structures. So there's the box, right? This stores an integer, this stores an integer too. And you can't my bad. I'm thinking about C++, which is a different language. It's integer in full. In C++, they just say int. Right, so int and then delete that. So all of these are integers. You can't miraculously store a string somewhere there. You can't. It's impossible. You can only store things that are of the same type. What if we want to create a container of multiple values like an array? It's similar to an array, right? But this time around, we want to switch the data types around. For example, I can have an int, I can have a double, I can have a string, I can have a char. So in order to do that, we achieve that through what I call a record structure. Remember, an array, it usually has a name, right? So the name is going to be somewhere here. Let's say it's an array of marks. And then you access remember the formula for arrays, they are stored as indexes, right? So that's why when you get a value, we say the array's name marks, then you pass in square brackets to specify in which position we want to go to. So if you want to go to position 0, this gives us the box at position 0. And then we can say that we want that box to be displayed via the console, something like that. Or you want to initialize it maybe to 33. So what this does, right, it looks for an array named marks in your computer. So it looks, and then it found the array named marks. Then we use square brackets to say go into that position, which is this box over here. Then we use the assignment operator, which is that equal sign symbol, which means that insert or put into this box at that position, insert the value 33. So this is what Visual Basic does. It's going to come here and they take 33, right? And then that 33, it's going to try and put it inside the box. But then remember that 33, you need to make sure that it matches the data type with the data type on the box. So this will go inside the box, this 33, right? So this is how arrays work. You use the positions. With the record structure, it's still similar, but the slide there's two differences. You're no longer using indexes. You actually use the variable, the box's name, right? So no indexes, no positions. And you can have different types. Why would it be important to create a record structure? Let me give you an example. For example, let's say you have a record studio. Let's say you want to create a type. Remember, all we are doing right now, right? We are technically defining a new type. That's another reason behind a record structure. We are defining a new type. So yeah, so that for you guys, you don't use things like private, blah blah. So I'll just declare it the way you guys do it. So Visual Basic, okay. So you have structure, right? To tell Visual Basic that you want to create a record structure, followed by the name. So this name that you provide, remember what I said, another reason for creating a record structure is so that we define a new data type. So what will you call the data type? It only makes sense to call it the thing that it represents, right? So let's say I want to create a structure for some student. So I want to define the data type student inside Visual Basic. So I'm going to call it student, and then I need to end the structure. Structure. And then inside the structure, you declare variables. Remember what I said, that it's unlike an array whereby you have indexes. You now have variables themselves. So basically all the boxes inside of that record structure, they have their own names. You don't access the boxes via indexes. Here we are forced to use some other methodology or some other approach because the boxes they have no labels, as you can see. So the computer can't tell them apart. So we decided to use indexing or positions to be able to tell them apart. That's the whole philosophy behind arrays. Then now we have record structures, which do something similar to an array, but slightly different. So it's different in two ways. You're no longer indexing, meaning you don't use positions to get to the variable, since the variables themselves, they have both things. They have a data type and the label on the box. So we can just use the label to extract what's inside the box or change what's inside the box. So just like you declare normal variables, you'd say dim, but then remember you're defining a type called student. It only makes sense to create variables that talk about a student. You can't be coming here and you're saying, for example, relationship status, right? That's not necessary. That's a private life thing. It's a personal life thing. It's not necessary. UJ doesn't need to know about that. Or maybe if you want to be more specific, you can call this type UJ student because it represents a UJ student. UJ don't care whether you are single or dating. Technically, but to be honest, they shouldn't put that there. That's none of their business. That doesn't count as something that represents student. And also, for example, how many beggars you can eat. That's not necessary. That's not part of a student. We need information or variables that represent a student. So let's start with something simple. For example, a name as a string. We would want to store the student's name, and then we want to store the student's surname, right? And we also want to store the student's age. Obviously, age is going to be an integer. And then what else can we want to store? Maybe their password, things like that. But I will not complicate it I will not add any more variables. It's up to you. You can add more. I'm not going to do that simply because it's going to take too long to draw the diagram. So that's why I'm only creating three. Then when it comes to record structure, it's similar to this, right? Very similar, but slightly different. So when it comes to record structure, it's like this. You have this container, right? It's basically this type that you've created, and then it's going to have a name so that we technically, yeah, this actually works as a template. This works as a template. Then you need to declare a specific student. You need to use the name of the record structure to create a student. So you'd say, for example, UJ student, and then we call the variable student, just student like this, no semicolon. Right? It's just student like this, right? You see, my bad. I keep mixing languages. It's dim student as UJ student, right? So you've declared a specific student of types UJ student, which means that this student it represents, we have all this information that represents this specific student. So to make it very clear, let me actually call this student one. So now in my diagram, the way the diagram works, right, is that you have a you have a diagram for a specific student. That's why I showed you how to declare first. So for this specific student named student one, because the computer does this, it comes here, creates a record structure to represent a student, and it uses the variable name, which is student one. So we now know that everything that's stored here represents student one. Then we're going to have boxes, right, as usual, which is the variables. In this case, how many do I have? I have one, two, three, name, surname, and age. So let's create those. And then we're going to have, as you can see, they're just stored in here. There's no positions. That's why we decide to use the variable, like to continue using like declare them, the variable names. Um, Let me increase the font. Because if you don't declare the variable names, how are you going to access the boxes? You see, it becomes impossible to access the boxes. Okay, let me be lazy and copy this over here. Yeah, so we have the first one, which is a string, right, which is the name. And then we have another string here. And then we have another variable, which is age, which is of type integer. So there we go. So there's the boxes, right? So let me make this a bit larger. And then also make this a bit larger. Also make this a bit larger. Okay, and then do this like that. Yeah, so this is a bit better. So now this is not done. Still need to give them the labels, which basically describe what that box stores. So this stores the name, That's the label on it. And then the next one stores the surname. That's the label on it. And then the other one stores the age. Then this is how a record structure would look, right? This is just an example of how I would model it so that you can see it. So there's the record structure, right? And this actually represents a specific student. So that's why every time we want to access things from here, we have a specific format or approach to do that. So then now, how do you tell Visual Basic that you want to initialize any of these boxes? Let's use this, one of them as an example. Let's say age. How do you tell Visual Basic you want to initialize the age? So you need to start by referring to which student, which record. They're called record structures because there's multiple records. So this whole thing over here, right? This whole thing over here, you can call it a record, right? So it counts as a specific record. So this record is referred, we can refer to it via this name. So that means if I want to access age, I need to tell Visual Basic that go to this record first, then get the age inside of that record. We do that via what we call the member access operator, which is simply a dot. So a dot, we call this the member access operator. Why member access? Because it accesses a member. So you can, another way, you can also view these things as like members. For example, right, let me tell you what I mean. For example, okay, think of it in this way, right? In another way, you can picture record structures. Think of it as like houses. Each house in your neighborhood, think of it as a specific record. Then the people inside them, think of or furniture, anything inside of the house, we call that the member. You're a member of that house, right? Or that family, whatever we want, however you want to view it. But we are viewing it in terms of a house. So you're a member of that house, right? So if you want to get a person, a member from that house, shouldn't you first things first, go to that house? So you need to know which house. Like for example, its address. That oh, this is 32 Richmond Avenue, right? That's where I can find that specific house. In this case, that specific record. We get the record via the student one. So this student one acts like as an address in a way. So you're gonna say student one, meaning that specific house, then use the dot to say go inside of it and access, you choose any of this. And you need to make sure the case is very, very important. If this name starts an uppercase letter N, you need to do that. Even though Visual Basic is lenient, but don't depend on luck. Luck is something that fades over time, so don't depend on luck. Make sure you type right things. So Visual Basic sees this line of code, right? It sees this. So far, I haven't written, I'm not done yet. Oh, it says, oh, you want this record called student one. How does it know it's a record? Because you're trying to accompany a dot on it. If you try to use a dot and it's not a record, it's gonna crash. So it double checks, are you sure that this is a record? If it is true, because it's gonna go here at the top, it's gonna find out, oh, it's structure, it's a record structure, so it's fine, it's allowed, this is allowed. So there's that dot. That dot, it means go inside here, which is basically, you see this whole rectangle around it. That represents the whole structure, right? For example, it represents the house. Then inside the house, there's you, your sibling, your other sibling. So this is all of you guys, right? To go inside the house, you use the dot. So that dot, you can think of it as like opening the door, the main door, and going inside the house. And then after the dot, you tell Visual Basic what thing do you want to take or you want to access. So I want to access age. So I'm going to say dot age. And then it's up to you whether you want to print it. If you want to print it, it will be just like this, right? But passed inside the right line method. In this case, I want to initialize it first. So I'm going to say is equals to 120. So that's basically how the record structure works. So that means every time you want to use things from the record structure, you always have to specify which record. because you can have multiple records. As we're gonna see on the slides, that you can have an array of that record structure. So basically, you can say as, right, and then you say like this. Why is that allowed? It's allowed. It's possible because why? UJ has a lot of students, right? So that means you can have more than one student. So it can be an array. So it's possible. In this case, we are looking at one specific student here. That's why we didn't put the round brackets as an array, because we are looking at one student. If your application or your app requires more than one, then you specify how many students are there. And obviously, since there's more than one student, you'd actually call these students, declare it in a different way, call it students in plural, because it represents more than one students. And then this is how you'd set the value, right? So this is how you'd set the value. But make sure, remember, Visual Basic is very strict. It checks the data type. So it's going to check what's the data type of this and compare it to this. If they don't match, it's going to crash. So be very careful of that. Then to print, you'd simply just say console.writeLine, and then you pass in the variable. But we need to always specify which record are we referring to, or which student are we referring to. So we're referring to student one dot his age, and then we print his age. We do it that way because remember, you can have more than one student. So basically, you can have a copy of all of this, right? But then it's no longer student one, it's now student two, which is another student, right? So that's why you always have to specify which record, because you can have more than one. So I hope that makes sense. And then, yeah, let me just illustrate this line of code over here, this one. So you told Visual Basic that you want to go to this record. So Visual Basic where it goes inside, right? It's like it searches, is this student one? Nope. Is this student one? Yes. Okay, so we found student one. Then it reads the dot age. Oh, so that means you want to work on this box. So it goes to that box for student one. Then it looks on the right hand side of the equal sign. It says, oh, 120. So you want to put that into the box. So it does this. It takes that 120 and then it shoves it inside the box. That's basically what's happening, right? That in the line of code. So I hope that makes sense. So that's pretty much record structures, and that's pretty much so nothing much changes because it's also possible. Remember this type, it's also possible within the record structure itself to have arrays. Why? Because that's what it means. That's what we're trying to represent. For example, remember each student has they have a profile on Eve, right? Where you can see your marks for each practical. So that means I can have a practical mark array. And okay, this is very, very important. Very, very important. In Visual Basic, you cannot create a constant array, basically a fixed array inside the record structure. So you can't say dim practical mark and put a number here. No, you can't. So you always have to leave it empty, even if it's fixed. Then you redeem it to that exact number somewhere. So you say redeem and set it to 10, even if you know it's fixed. That's just how record structures work. And then as integer, because your practical marks are stored as integer. So yeah, so it is also possible to do this. But just always remember that you need to specify which record, or in this case, which student, before you use the array, or else it's going to be confused. So I hope that's clear. Do you guys understand? You can put a thumbs up if you understand. Okay, and Singita, do you understand? Okay. So I'm just gonna leave this here. I'll save this image and share it with you. I'll try to share both this and this. I hope this website can allow me to do that. So let's go through the slides, right? But I've pretty much explained everything that's on the slides. Everything that's on the slides, all the possibilities, I've explained them. Because redeem, right? We don't have to talk about that. That just basically you create a dynamic array, meaning you do not know the size, someone else knows the size. So you ask the person, what's the size of the array? Then once you've gotten that number, then you use the keyword redeem to give it an actual size. That's pretty much what redeem is all about. It's when you don't know how big the array should be, so you depend on someone else to give you the answer. So I'm gonna put it in read mode. So we're going through record structures, right? So this is the overview. Basically, what should you expect to understand from this lecture slide? You're gonna know what the record structure concept is all about, how to declare it, accessing, assigning structures as a parameter or as a return type, arrays and structures together, right? And then, yeah, this is just talking about that. So far, you guys have been using the built-in language data types, right? Meaning the data types that Visual Basic came with. Now we're going to be taught on how to define our own composite data types. By composite, right, it means that it contains other types. Basically, it's a type that that is created through combining other types. That's what that composite data type part means. Which is true. It's 100% true because look at this type. It's called UJ student. Doesn't it use other types? It does. It uses a string and integer. You can also use a boolean, any types. So that means it is true. It is a composite data type. It uses the built-in data types. Yeah, as I've stated. The first composite data type that was of the array. Yeah, which is true because if you check the array, isn't it also made up of other types? Even though it's the same type, but we've created a new type based on other types. So technically an array this is a composite data type. And then record structures, on the other hand, allow us to combine values of different types into a single variable, which is exactly what I stated when you started this session. That record structures, it's a way to combine values of different types, which is at its core what the record structure is all about. Whereas an array, you combine only the same data type. And then the record structure, as you can see, they were trying to show you what a record structure looks like, which is basically this diagram over here. As you can see, this diagram, it has different types. Even though I might have two int strings, but I also have an integer. So that's basically what that diagram was trying to explain, which is this that I was explaining here. So don't be confused by this. Because you see, these are different tools. So it's like different data types. And then this is how you declare the record structure. You tell Visual Basic that you want to create a structure, which is a record structure. And then you give it a name, which is the record structure name. Basically, this name that you're going to give it, it should describe the thing you want to model or represent. If you want to represent a UJ student, you call it UJ student. If you want to represent, for example, a UP student, you call it UP student. If you want to create one for vets, you call it vets student. You need to give it a name that describes what the record structure represents or talks about. And make sure you use a noun. No plurals, don't use plurals. Don't say students. That's very wrong. Always use singular and it needs to be a noun. So that's student. It names something, which is naming a student from a specific university. And then elements is basically all the different variables that define struct name. That talks about what the struct is up. Did all the different variables that make up this new type. Because remember, record structure is a new type based on existing types. And then is a list of identifiers and in the format, blah, blah. Then to declare a variable of this type over here. They didn't phrase it well. They were supposed to say as struct name because the struct name is the new data type, is the name for that new data type. So you have to say as struct name here. They could have made the slides a bit easier by doing so. Oh, like enough, we made the same example. So yeah, you see, we have a student. I called it UJ student, but still represents a student. Consider the creation of a record structure to represent an Informatics 100 student. So we create a structure by using the keyword structure, and then we give it a name, which defines a new type. So the new type will be called student. And this new type uses these variables over here. And those variables, they're of those types. Notice we do not tend to use the type prefixes as members of a record structure. Yeah, you don't need to put a type prefix. By type prefix, right, they mean you don't have to say, for example, you don't have to use type prefixes as the member. I think what they're trying to say here, they're trying to say if you called it name, we didn't call it str name. We didn't put a prefix str, which just simply means, oh, this is a string. You don't have to do that. You don't have to put those prefixes. And then accessing, we talked about it. To access the members of a record structure may be individually accessed by the way of the dot operator. And like I said, it's called a member access operator because it accesses a member of that record structure. So because the variables inside the record structures, they're called members. So if you're accessing a member, so that means this is a member access operator. It's an operator that allows us to access members. You must play around with English in order to understand some certain words. And then you have the record structure name, right? Meaning the variable name. They're very wrong for that. The way they do the slides is missing. They mean this variable name of type record structure. That variable name, which is student one in this case. You need to use that followed by the dot, followed by what you want to access from the record structure. So yeah, and then member name, because like I said, any variable that forms part of the record structure is called a member. For example, like a family member. Where have you seen the dot member operator before? Remember on console. Mind you, I haven't checked the slides. I'm just assuming. You remember when you wrote before we continue, I'm just gonna take a guess. Remember we use the dot when you have console. Console dot right line. So you guys have been using it. It's similar. But then a console is actually an advanced record structure because the record structure only allows you, oh, that's another thing. A record structure you're only allowed to pass in variables, not functions. But then there is an advanced, right? Basically, it's like it's still the same thing, right? It's still a record structure, but it's like a pimped version of a record structure. And an example that I can give that you girls can understand is like, for example, you're a girl and you put on makeup and you buy a weave. You've pimped yourself, right? You've upgraded yourself, but it doesn't change the fact that you are still Mbali or Lirat or whatever your name is. You're still you. But then you are like advanced now, levels, right? So it's basically the same thing. So this console is actually some advanced record structure whereby it allows you to actually declare functions. You guys won't be taught about that because that's advanced. For us, we were taught in second semester. So yeah. So let's see. It should be console. Yeah, I see here we're initializing all the variables here. Fun fact, this guy that they're talking about here, this one over here, is the guy who created the operating system that VPL uses. So yeah, it's not just a random name they chose. Lecturers read. So yeah. Oh, they didn't tell you. They want you to use common sense. You see, They asked you the question, but they didn't show you, they didn't tell you. But then there's the answer already. See, we've been using the dot this whole time. So just know the dot means go inside and access that thing, whether it's a variable or a function. In your case, you're only dealing with variables because you guys, you don't go beyond record structures. You don't do the advanced record structures. Assigning structures, right? Structures can be copied one element at a time. So basically, you can't copy multiple elements at a time, right? Basically, this is what they mean. Let me show you an example. These slides have. That's why I don't like geniuses. Geniuses, they're very bad when it comes to design and doing slides and things like that. They're very bad, Shem. Because look at well, how are you supposed to understand here? From here, how are you supposed to understand? Makes no sense. They're supposed to show you declarations separate. So let me show you what they mean. They mean if you say it's DM student 2, right? Remember, we also have student 2. It's a UJ student. It's of type UJ student, right? What they mean is if you want to copy values from student 1 and store them into student 2, you don't do shortcuts like this and say student 2, it takes in student 1. No, they say this doesn't work. This is wrong. You need to copy one by one. So you need to say the age of student 2 takes the age of student 1. So one by one. You can't copy the whole record structure. There's no such a thing. So there's no such. So that's what they're trying to explain in this one page of the slides. And like I said, they're very bad with making slides. They can improve, they should be improving them. So here they're trying to show you an example. And let me see. Oh, my bad. They said you can, not you cannot. They said you can. Let me think about it. Yeah, they're right. Yeah, they're right, you can. I'm just thinking about the knowledge that I have from computer science. Yeah, you can. Because why do I say so? Why do I say you can? There is another reason. Okay, let's try to back up. Let's try to understand this, right? If you take this example a step further, right, you can imagine that a computer actually has addresses. Everything that is saved on the computer is saved in a location, which makes sense because computers were made by people like you and me. So this is what it means, right? So it means this whole record structure is stored in a specific location in your computer. So that location, that address, right? When you declare a variable like this here, over here, that address is actually stored inside this variable over here. That's why we create a variable because we are very bad. People are very bad with numbers, right? The computer to store those addresses, the computer uses integers and it uses numbers. And people are very bad with numbers. So instead of us using the actual addresses, we create variables. Basically, we give it a name. So this name is student 1. So it's better than having to remember something like this. Imagine trying to remember that. That's basically how it stores the addresses. So we can't possibly remember that because we are people, we are human beings. We're very bad. Our brains, they don't do well with numbers. But with words, names, labels, and things, it's perfect. For example, you can never forget that this is student 1. You know, you can read it. So that address, right, of where so basically what it does is it builds remember, this is how it looks in the computer. This is the record structure over here. There it is over here, right? So I'll actually show you a proper example. Let me switch up this example a bit. Let me change this and put it here. Let me copy this and put it here. Oh, let me do this. Yeah, my bad. Oh yeah, I can still put it that side. It's fine. So I'm gonna put it here and I'm gonna say it has an address of, it always starts with 0x. We call that hexadecimal. You don't have to know about that, but it's just called hexadecimal. So this whole thing, right? It gets created in a specific location and then it's given n address. So this now points is stored at that address, or it lives at that address, just like you stay at whatever address, at whatever rest you stay at. I agree that rest is an address. So there's that address, but then since people are very bad, this is a very small number. To be honest, the addresses can tend to be very long. So this is a very small example. So it's 0x11EF. It's a very small number, right? So you can maybe somewhat remember it. But then it's kind of difficult to remember that, so we always create variables. So instead, what happens is that that address is saved under a variable name. So student one, right? So this becomes, so I'm going to put it in this direction, right? So this becomes saved inside that variable. So that's why you can actually copy by doing, that's why they're telling you that you can actually copy by doing this. So I was wrong. It's not that you cannot, you can. Because the variables themselves of type record structure, they store the addresses. So when it's like this, right, it means student will take the address of student one, which is basically 0x11EF. So it basically does this 0x11EF. So now that means student two, it now stays at the same address. Technically, you can view it as like you now moved in with Chomi, right? So you stay at the same place. So your addresses need to match, right? So that means if you stay in the same place, you are sharing things, which means if you use one person to change the whatever to change the location, that address, right, it will affect the other person. What do I mean by that? If you and Chomi stay in the same place, right? If your friend Chomi bought a cranberry juice, right, and she put it in the fridge and was like, I'll drink it tomorrow, and then you decide to drink it, won't that affect Chomi? It will, because you guys are sharing things since you're at the same address. So this is basically another way to copy it. I hope that's very, very clear. I tried to be as basic as I could with the examples. So that's why here we can make a copy. But then remember, okay, it should technically be a copy. Yeah, it should be a copy, shallow, but then yeah, we won't get into the details. As you can see in this part, they do talk about the copy being shallow, blah blah. But then they said not yet. They'll talk about it in the next slide. Let's see if there is other slides. I hope I hope it ends here so that you guys don't have to cram a lot. So you can pass record structures as parameters. Whereby it shouldn't be that difficult to understand, right? Because remember, the name of the record structure acts as a data type. So use it the way you're using other data types. But then just know the difference is that the variable itself, it only stores the address. So you must actually use the dot to access the things at that address. So yeah, so you're gonna say student dot name, dot number, dot what. So that's very important to do that. And then you can, okay, if a subroutine is meant to modify a record structure, to pass it by reference. Yeah, so they're basically saying you should normalize passing the thing by reference if you want to change it. For example, if you pass a record structure and you see when you leave it like this, by default, we say it's passed by value. By value, it means a copy is made. If you pass it by reference, it means that you're passing it by reference. By reference meaning by address, which is basically that example that I was talking about, that it's technically the same thing as you going to stay with Chomi at that same address. So that means you guys have moved in together. So if I change something, it affects the other person because we stay in the same place. That's what pass by reference means. So that's why if you want to change it, you obviously have to pass it by reference because you want to go and stay in the same location as that record structure where it's located. So that when you make changes, they also affect the other person. And then, yeah, so as you can see, they now passed it by reference. So now it should actually change it. So when you pass by reference, it should actually change it, meaning whatever assignment statements you wrote inside the subroutine, right? They continue to exist even after the subroutine. So yeah, you need to understand that. And one thing you need to also understand, right? If you don't pass, whether you don't pass by value or by ref, you don't pass it at all. Remember, that's still allowed. By default, it's by val or by value, meaning copy. So just be aware of that. And then table based, they have jokes, ne? Uno, duo, trio, okay. So you can also create record structures as arrays. Like I said, it's just a normal type. So you have array of students, meaning you have three students. In this case, there's three, as you can see. You see, there's three. And then remember, we said arrays are zero index. You might ask yourself, if there's an array of students, then how does the diagram look? To be honest, it kind of becomes complicated, but you can still kind of see it. So this is how the diagram would look. So let's say, okay, this, right, you guys can see it, right? We did explain that. So I can delete this example and put it back to the way it was because I want to demonstrate, I want to explain arrays. So remember, this represents one record. When you say an array of records, right, it means more than one of these. And each of these is stored at a specific index. So I'm going to scroll down here and show you an example. Hey, this will be a very big diagram. So this would be, yeah. No, this is not the one. I want this one. Whereby it can stretch in both ways. And then I'm gonna take this record, cut it. You need to cut it, cut it, cut it. Like OT Genesis once said, you need to cut it. So I'm gonna cut it and then copy all of that, put it next to here. Yeah, I think I'm also gonna share with my other students because this is like really deep. This is a deep explanation of this thing. Yeah. Okay, seems like okay. It's fine. Let me copy it from outside. Let me just do this because I don't want to be repeating myself. Yeah. So remember, it's an array of record structures, meaning at each index there's a whole record. So that means this part here that I've highlighted this. Let me actually color it so that you guys can see it. Make this blue. So this blue one, that's index 0. The pink one is index 1. And then you can have more. So this is basically how it looks as an array. So this will be actually index 0. I think diagrams tend to help make the explanations more understandable. So let me enlarge it bigger, 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 bigger. Yeah, that's big enough. And then stretch it a bit, yeah. And then copy, there we go. And then this will be index 1. So this is how it would look like as a record structure of array of record structures. So on the slides, it actually, this part over here, that's what it's trying to model. That's what I was trying to model there. But then you'd have an extra student because there's 3. So obviously, this is the process. You need to index first which record. So that array, whatever you've called it, whether you've called it students, whatever you've called that array, you specify the index. So they say index 0. So at index 0, we have a whole record structure. So I need to, after indexing, I need to say dot, because at that position, there's a record. Remember how we use the record. But then since it's arrays, remember arrays, you don't put labels on things. So basically, I need you to understand something very important here. The thing that's stored at that index is the record, not the variables. So don't say, why don't you remove the labels for the variables? No, the variables are in the record structure. The thing that's in the array, it's the record itself. So we should remove the record, the name for the record, because we're no longer accessing it via names, we're accessing it via positions. So we go to position 0 and we access it. Position 1, we access it. So that's why on the slides it looks like this, right? The new student. What did they call it? Let me see the record structure. Um, oh, they are using a function. You see, they're calling a function. You see this function? It returns a student, whereby that student we've initialized it to these default values, and then set it to give back that student. Since this function expects you to give back or return a student. That's why here we have new student like this. This is what this part is representing. We are calling a function that creates a new student. And then we can, since these indexes, they're always going to be repeated, right? So we're just going to use a for loop for that. Not indexes, the lines of code. Remember we have 3 students. So that means these lines of code over here, these ones, must be repeated 2 more times. So why not stop doing that and just use the for loop? Because why? We have a pattern here. You see, we start counting from 0, go to 1, go to 2. So we can use 0 to 2 and make the step 1, meaning it increments or increases by using the number 1. It starts at 0, we go to the next one by increasing with 1. And the increase is done when Visual Basic reaches this part, next I. That's when it increments or it increases based on the step. We did talk about for loops, so that shouldn't be too hard to understand. As I've talked about, you can have an array within the student record structure, and it can vary. But as I've stated, even if you have a fixed array, it'll crash if you try to pass a number there. So you always have to redeem. To be honest, even if you have fixed or dynamic, you always have to redeem if that array is actually stored as a variable or as a member of a record structure. So yeah, this is just examples. As you can see, we are redeeming here, which is simple because remember what I talked about. Before you use that variable, you need to tell the Visual Basic which record are you referring to. So I'm referring to rec student dot. I want that student's practicals, and I want to initialize it to this int number of practicals. And then I put redeem. Yeah, and then I think everything else should be pretty much the same. Yeah, there's nothing more to explain because here just full of examples. How do you use record structures as arrays or as collection of arrays and things like that? This is just those examples. Let me check. Student, yeah, it's basically the same thing. Arrays reference parameters and shallow copies. Okay, yeah, that's pretty much because all of these things, right? It's basically examples on how to use the record structure, of which is basically the whole thing that I've been explaining. Yeah, they're just repeating with examples now. All of these are just examples. So yeah, I hope arrays, record structures and arrays are a bit understandable now. Do you guys understand? Can I see a thumbs up? Okay, that's good. Um, yeah, so that'll be it for today. Do you guys have any questions before I stop? But yeah, this is basically the whole thing. If you can understand the diagram and understand the explanations, you won't ever have issues with this thing. Any questions?
I don't have any question.
Okay. Mahutsu, or I don't know if I'm butchering your name. Do you have any questions?
No, I don't.
Okay. That's fine. Then that'll be it for today. We can have another session maybe tomorrow. Then we can, I don't know, maybe do a mock test.
Yeah, we can. Can we please do
Yeah,
a test tomorrow?
Okay, so
yeah.
what time works for both of you guys? But it has to be before 6 p.m., right? Because from 6 p.m. I tutor first years, ComSci 1A, and then 8 p.m. I'm tutoring ComSci 2A. So I end up finishing around 10 p.m. somewhere there.
Won't the same time as today be good, Senator?
Yeah, it will be fine.
Okay, so 3 p.m. tomorrow.
Yes.
Okay, so hope you guys have a lovely day.
Thank you.
Thank you. Same to you.
Sharp.